Hello everyone, welcome to the Electronics Introduction with Arduino, which is part of the Digital Design and Making 101 workshop series. My name is Rich McHugh and I'm the manager of the Digital Scholarship Commons in the University of Victoria Libraries. Today we're going to be covering Arduino, do a quick overview, and then get into hands-on activities. Just to give you a little bit of sense of what you can do with Arduino, one thing you can do, for example, is, let me just get my laser pointer out here, is use a motion sensor device hooked up to the Arduino that will light up a little LED light when it senses motion. Another thing would be an RFID door lock using a strike plate for the door with a solenoid. Another cool one that might be interesting for some anyways is to repurpose broken or old Halloween animatronic devices that maybe aren't being used anymore, and repurpose them so that you can orchestrate your own sort of show or presentation of Halloween or Christmas devices that would otherwise potentially end up in the landfill. Another one, and this is something that I've considered doing several times, is using an Arduino to measure the amount of moisture in the soil so it can keep plants watered appropriately so they don't die. I've killed, I can't remember how many plants over the years, so this would be really useful for me as well. And then last one, and this is one of our activities today, would be a COVID sensor. These are two ultrasonic sensors that measure distance. And the way the Arduino inside this medallion is programmed is if you're less than 2 meters away from someone, the green light will light up. If you're closer than 2 meters, then the red light will sign up. So again, just a quick overview of some of the things you could potentially do with an Arduino device. Some key concepts that are important to know, to start with sensors. An Arduino device on its own can't do anything. You need sensors and devices for output and resistors on the inside, but some examples of sensors are a light sensor, mechanical switches, motion sensors, heat sensors, pressure, GPS location, infrared, and more. Now, resistors are what regulate the flow of electricity between devices, so there's not too much or too little. If you have too much electricity going to an LED bulb, it could burn it out. If it's too little, then it's maybe not bright enough to be visible. And we'll be using, and the programming is another element, telling the Arduino what to do with the sensors and output devices that it has. Today, you're not going to have to worry about doing any program other than copying and pasting programs that we'll provide. And then you can, if you want to, you can modify them a bit. And then lastly, there's output devices, things like LED lights, sound, a little speaker for sound, digital display, motors, servos, solenoids, and more. In terms of how these different things work together, we've got a miniature Arduino here, and a sensor that it uses here in this case is the ultrasonic sensor. This is for the COVID 2-meter sensor. We've got two LED light bulbs with resistors to regulate the flow of electricity to them. And then the programming happens here. These two things are a battery and a battery controller. We don't have to worry about them today because we'll be using power from your laptop. But just an example of how things are connected together in a way that it makes it easy for you to recreate what's going on so that you can follow the instructions for an activity to make a device of your own. One thing that some people sometimes struggle with conceptually is why we have resistors. And again, like I mentioned before, it's to regulate the flow of electricity. So for example, if you've got a valve and a reservoir of water, you can control the valve so that you don't have too much or too little water going out of the hose. And these are the formulas down here that you can use to calculate how much energy needs to get to a particular device. One of the tools that we're going to be using today is a breadboard. Over here on the left is a breadboard. It's not obvious, but for example, all of this one outside row here, all of those are connected together, all of those little dots. As you can see here, the inside row are all connected together, our dots are connected together. And by convention, you have power on the outside and then the ground on the inside. And then in the middle, the holes are connected this way so that you can plug things in and move the electricity or signals around without having to do any soldering. So it makes prototyping much more quick. just to show how a breadboard would work, let's say we've got power going to each of these resistors and then bulbs, and then these bulbs are connected to the power through here, through the short legs, and then the long legs go over here, which are connected to the ground here, so that it can complete the circuit by going through here. We got power. Power coming through these two, and then the ground there going out that completes the circuit off the image here. There are different types of Arduino boards. Today we're going to be using the Uno 3 board here, which is a prototyping board. It's quite flexible and easy to use, but you wouldn't probably make a device out of a prototyping board just because they're so big and bulky. Here's an Arduino Nano. It's just as powerful as the Uno, but it's much, much smaller, as you can see. And one of the reasons why it can be so much smaller is it doesn't have these little places where you can plug in wires. You've got to solder the wires to the board there for them to work. So again, it's smaller, but it takes a bit of extra work to connect things up. Here's an example of a product that was originally done with the Arduino prototyping board that they've actually created their own Arduino board customized for their purpose, and this is the FarmBot. It has a camera so it can look at the plants, can water them, it can actually pick weeds as well, which is pretty amazing. And here's what their board looks like. This is the Arduino chip here, and then it has a bunch of specialized connectors to connect to the different devices on the FarmBot that it needs to be able to communicate with. Another Arduino prototype that they've turned into their own Arduino board is the Smart Citizen Kit, and this helps people connect data on air quality, temperature, humidity, other environmental data like that. And then they've added a Wi-Fi chip on there so it can talk to a server that a Smart Citizen group runs so that they can collect that data from different parts of the city and country and share that with other people. Then lastly, this is a teaching device. It's the Key Studio IoT Smart Home Kit, and this is to help teach people about how smart home devices work and how they can be controlled. Which is an interesting use case as well. In terms of our projects in the workshop today, the one that I want everyone to start with, especially if you don't have any experience, is a blink one where you just make a light blink, and it's quite simple. It's actually not on here, but we'll work through that one together. Then we've got a levometer, light theremin, which makes some spooky noises, the electronic die or dice, and then a lucky 8-ball and the COVID sensor. And in terms of difficulty, the easiest is probably the levometer, and then the light theremin, electronic die, and COVID sensor are sort of intermediate, and then the most difficult is the lucky 8-ball, and the only thing that is difficult about it is all of the wires that you've got to get in exactly the right place. Other than that, it's it's just copy and paste coding, so it's not a big deal to do. So this is the schematic or the diagram for the blink activity that we'll work through in just a second. And then, like I mentioned, after that, you can start on your chosen project. And you can see there's a link in the notes below to the webpage for this workshop, and you can go directly to those activities down near the bottom of today's topic. So let's get started. And if you have any questions, please let me know. Have a great day, everyone.